Hello everyone, and welcome to Orbalance Tech. Today I'm going to be showing you an oxy-hydrogen engine I designed and a model I 3D printed. If you have seen the channel logo, or thought a little about the name, or just read the description, you must have realized this is a space-oriented channel. So why am I making a jet engine? Well, that's where the oxy-hydrogen comes in. For those who don't know, oxy-hydrogen is a highly explosive gas made up of hydrogen and oxygen. In my case and most others, it is produced from electrolysis, the process of splitting water into hydrogen and oxygen using electricity. Since the gas already has the perfect ratio of hydrogen and oxygen built in, no air is necessary, hence why it qualifies for a space-themed channel. Here you can see the process of electrolysis. It usually only requires about 2 volts. The positive and negative electrodes go into the water. Water conducts. It is split into these gas particles that move up and out of the water, and this is the equation. All the chemistry people yelling at me right now. I know this isn't the official electron-oriented equation, but it's simple enough to understand. And then this is the bonds breaking. While I won't be testing the engine in this video, I already have my electrolyzer. I am using 6 layered steel plates, about 16 centimeters in diameter, with about 18 volts at a max of 10 amps applied to it. I'm using a desktop power supply for this, attached here. Don't mind this is just baking soda residue. That's what I'm using for my electrolyte to make the water more conductive. At the top, you can see the buffer tank, designed to keep water out of the system. This is meant to be a high-pressure electrolyzer, and since I'm using plastic end plates, sealing has been an issue. However, I recently reprinted them. These are the old ones. You can see there's some cracking here, as well as some warping and other damages here.
Alright, so here is the engine model. I do all of my designing in Onshape, which is a really great CAD software. To be clear, I'm not being sponsored by anyone, I just really like it. So here is the exploded view of the engine. As you can see, it has a lot of parts, as well as a 3D printed 6000 series bearing right here, which isn't shown in this view. I wanted to avoid buying hardware, so the only non-3D printed parts are the screws and the motors. Now back to the normal model. This is where the oxy-hydrogen is fed into the engine, these 2 ports here. There are 2 ports for maximum efficiency, of course assuming the source is high pressure. In addition, the bearing that constrains the shaft, the main shaft, is secured right here in the intake cone. Side note, the electrolyzer is only for filling a tank, not for directly feeding the engine. That would be a little too tethered between wires and tubes. After entering the engine, the motor attached right here spins this shaft. This in turn spins the compressor wheel right here, which pulls the gas into the compression cone. I know traditional jet engines have a multi-stage compressor, but because of space constraints and simplicity, I decided on minimal compression. After the gas travels through the cone, it is ignited after passing around this plate. It is ignited by a plasma lighter secured right here in this hole. As the gas exits, it spins this turbine wheel, which in a perfect world would make the system self-sustaining. The nozzle is a variable thrust nozzle, which means depending on how large the diameter of the nozzle opening is, the amount of thrust changes. And this is controlled by a servo motor, an MG90, secured right here, driving this gear. And you can see an animation of this here. So it can open and then close. I decided on a ball and socket system for this nozzle. It's a little bulky and a little crude, but it was easy to design and was easy to assemble. Side note, I also did hide several parts from this demonstration, including spacers and some keys, because as you probably saw, the turbine and the compressor have a key slot to avoid them spinning on the shaft. But I decided not to include that in this demonstration just because there'd be a lot of parts that aren't necessarily important to how it functions.
For comparison, this is a simple diagram of a turbojet engine. As you can see, the compression system as well as the ignition system are much more complex than my engine. This here is the physical model I 3D printed of the engine. I'm controlling it with this control panel that I designed for this project. It uses a TT-Go-T display right here as the main controller, as well as 2 buttons, a 3rd button, a potentiometer, 2 toggle switches as the physical interface. Side note, these toggle switches and this button are currently hooked up to 2 of these wires that are not used for this motor, which won't be in use for this video, but if I do make a testing video, that would be the plasma lighter ignition system. As you can see, the engine isn't very large. Hand comparison. But here is how using this potentiometer, the nozzle can open and close. Here's a little look at the internals. And the shaft spins, let me set the engine up, right? The shaft spins when I press this bottom button. Takes a little encouragement because the current limit from the ESP32 in the control panel is a little low. And I'm powering it from a generic USB power bank. For assembly, I use small button head screws like these from metal building sets like this one. Not the exact one, just similar. And for motors, I use this generic 5-volt DC motor from an RC car and the aforementioned MG90S servo motor. So yeah, this is the oxy-hydrogen engine. No fancy gas flow calculations were done for how the gas would exit the nozzle or spin the turbines, so it probably won't work perfectly, if at all, but I'll try to make a video detailing some testing. I'll also be releasing a video soon on my electrolyzer and the project it was really meant for. Think Star Wars, an elegant weapon for a more civilized age. I will be designing a display stand along with other upgrades for the engine. So if anybody would like the files and a video detailing how to assemble it, leave a comment down below. Thanks for watching, and live long and prosper.